Okay, so now we will start with the NSI session, which was initially planned to have 3 presenters, myself, Radck, and Guy Roberts, but unfortunately, as Guy was unable to come, Radck will present also his slides. And the session has 3 topics, 3 presentations. One will present the new concept of decoupling the services definition from the core NSI standard. Then Radck will also present some new discussed features for NSI version 3. And then I will close the session with a description of the things that we are doing in Autobahn software implementation. I think, especially in my presentation, but I assume the same applies also for Radck's presentation, it would be very useful if you supplied us with feedback and comments. But due to the time constraints, let's say, it would be better if we leave questions for the third slot of the session after the 2 first presentations by Radck. So.
I hope it's working. Okay, so the first question is, who is not aware of NSI? So have no knowledge or no idea what NSI is doing, please raise your hand. So we have all NSI people here.
You have a mic, you need to speak louder.
Louder, okay. So everyone knows more or less what is the purpose of the NSI and why I'm standing here and doing this kind of things. Okay, so this is the presentation I get yesterday afternoon from Guy, who gets sick. So apologize at the beginning that I'm not really familiar with those slides, so the presentation may not be very fluent. Anyway, the NSI in general the purpose is to have some kind of a federation of providers. So as we have Jant, NordUnet, Pioneer, whatever kind of entrants, also the Glyph infrastructure, we merge them together and provide one global services among each other. So it's a kind of a federation. And as we talk about federation, there are a lot of things arise and requires of the agreements and negotiation, etc., etc. So what we did in the NSI, we create something called the service definition, and this presentation is about describing how the NSI understand the service itself and how we define the scope of the service in the NSI. The assumption is that each domain, while we talk about service, agrees on the type of the service, so they have a common sense, common understanding of what they want to achieve. For example, if you want to have a point-to-point connection on the Ethernet, you need to specify what kind of a technology, what kind of interfaces are you using, and it should be more or less constant along all the path. So the definition is in general built in a XML format. It defines specific attributes regarding the type of the service as well as the generic service attributes. NSI connection service, which is the abbreviation, the NSICS connection service schema, includes all those templates that is required to build a service, specific service definition, so to submit a request for a particular connection, particular reservation within the system. It's a bunch of template in the format of XML defined with the WSDL schema, so it's easy to adopt to any programming language and import into your software, just building on adapters on the top of it. So building an instance of the service definition is actually, let's say, 3-step model. There are more steps, but in general there are 3 main steps. So there is the NSI connection service schema defining very generic thing about the service itself. So it's, for example, include the start and end time. So this is the basis of the service itself. Now you have some kind of specific attributes that are connected very closely to the type of the service that you want to use. So you define the STPs, which is service termination point. This is the edges of the domain in general speaking, that we set up a circuit between, building a segments of the network. And you define some additional attributes like MTU or capacity that you want to require. There's of course a lot of them that you can define. NSI connection service using just a part of them, at least for demonstration, but there is a lot of place to define another one, depending on what kind of services are you using in your network and want to provide to the end users. And at the end, you may add something like the SLA or technology-specific things that you require monitoring or specific framing or whatever. This is the additional attributes that are not necessarily included in the definition of the service, but in some way you want to use them in your kind of a reservation. And those three components is building one service definition that you can request from a federation of the providers. So you submit this kind of a form to the NSA agent, and he can easily understand what you want to achieve in at the end. This is going to be a little more technical. So the NSI service definition schema, template schema, contains on a few more or less static fields which you define at the beginning of the requesting a service. So service description is just describing the purpose of the service. It contains several fields that is naming the service and describing what is the general thing that you want to achieve. Then you define the schema type and parameter types, which defines what kind of real service you want to achieve. So you have a connection and you use the schema type for the connection services. So NSI agent, when he gets this document, he reads the schema type and he knows, okay, you wanted a point-to-point connection from me, so I know how to understand how to read your messages. The parameters type and attributes types are the specific attributes that are used within the request to define in details what you want to achieve. So endpoints, as I mentioned before, a specific kind of technology things that you want to use in a request, etc. There's of course also error type, which is used in particular failure situation when something goes wrong, or you want to point out how to handle some kind of errors. Then you can use the error fields also for defining some additional things. So the types in parameters that you're using to define your own service, as the main thing is STP, which is a service termination point. NSI basing on those to define connection services. So if you have a domain, whatever is in that domain, let's say for NordUnet, it's a quite complex example, so you have multiple small endpoints connected into one unity. If you want to represent the endpoint, it's just a cloud with the edge points that is connected, for example, to Jant network or any other direct connection to neighboring or distance domain to abroad, whatever. And those points we abstract to the STPs. So we don't care that you have an Ethernet or SDH switch or whatever at the bottom. You have an STP, which means that you can connect to your neighbor. And we also assume, which is, I'm going to discuss that in the second presentation, we assume also that all the STPs are connected internally. So if I can enter you to your network through one STP, I can go with another outside. There are some restrictions, but this is not important at this moment. So this is the STPs, and all the connections are defined based on those STPs. This is the domain responsibility to understand what and how to map those STPs into real interfaces and real network services that you have in your own network. So we can, let's say, organize those STPs in the way of eros, for example. So we can define paths, setting up all the STPs along the way. We can make an order at least of them, and force or request the NSI for a specific path. So I can let it completely to NSI agents to do the path finding, or I can request a specific path going through the particular eros point. So I have flexibility here. Label type is a quite generic field. This is key and value pair of attributes, which some of them may be defined in the service, but the field is open, so I can also add my own fields if needed. So in general, if I have some additional things that I need to do in a domain, and I have two domains, like two NSA agents that understand those attributes, they're gonna extract it from the request. If they don't understand it, they ignore it. So it's a simply understand or not basic rules. It's not a problem. But this field gives a lot of opportunity for extending the protocols. If we find something useful, we can also put it as a standardized attribute or standardized parameter to the NSA service definition. the services has, at least the connection services has something like directionality. It means that I can set up the unidirectional path going just one direction, and I can do that bidirectionally. By bidirectional, I mean symmetrical in that particular case. So if I'm going to use a connection from, let's say, Pioneer from Poznan to here, to Copenhagen, I will go through Żant, and the reverse path is going exactly through the same STPs. It's just in a different direction. The unidirection means that I can set up only just a circuit going from Poznan to here and no way back. So, for example, I can get the acknowledgements through the regular IP connections, or however I want to do that, or do the reverse path as a separate service, routed differently from cheaper connection using cheaper hardware or whatever. So this kind of flexibility allows us to do a very complex or less or more complicated services. So there are at this moment defined three types of connections in the connection service. Simple point-to-point connections, it's just a generic type. It doesn't specify how you do that things. Then we have EVS and EVTS for the Ethernet-based services. Mostly these are used for the demonstration purposes at this moment. So we have Ethernet domains mostly in the testbed that we have already, and we use for the testing, validating, and evaluating the NSI protocol. Defining the base, I think it's on the next slide. The services can contain each other. So if I define a point-to-point service or EVS service, it extends the point-to-point. So the fields are the same. The EVS just add additional one. So there is a hierarchy and inheritance of services. This allows us to create a very generic service like point-to-point and then go into the details with other definition of the services, just inheriting the fields and adding new attributes and new parameters to the existing one in order to prevent repeating the same stuff all the time. So the simple point-to-point service just includes several more or less generic attributes. So the very generic ones are version, for example, because we're using different version of the NSI. We started with 0.1, we have 1.0, now we have 2.0, we are starting talking about 3.0, etc. So in order to assure that they can talk each other and understand each other and to provide a compatibility, in the messages, in the service definition, we also exchange the version information. We have schedule, which is the means start and end time of the reservation. So we define the scope in the sense of time when the service should be available. The service type as I mentioned, is a specific like point-to-point circuit or EVTS or whatever. Other is very generic field that you put any kind of an information. It's mandatory. We use it for the demonstration, but in general it doesn't bring very specific kind of information stuff. And then we have service-specific parameters. In this kind for this example, as point-to-point, we define the capacity. So we want a 1 gig circuit. We define directional, like we want to have a symmetrical bidirectional link. We can define the path. So going through at particular STPs from Poznan through Żant, going out from Żant to Nordinet, and then to a particular endpoint in Nordinet. We of course need to define the source and destination STP, so we know exactly when the circuit is terminated and started. ERO is optional, so it doesn't need to specify. We can rely on the pathfinding that is implemented in the NSI. Creating an NSI connection request. Okay, this is the steps how we create the request. So if a user or the NSI agent that wants to have a circuit, an application, whatever, who wants to have a circuit, he needs to implement the interface, which is called the NSI requester agent. It's just a few methods to send the request and receive some feedbacks on how the request is processing, plus some cancellation, regular things, CRUD actually things to manage the connections. It needs to include the service type and fill all the fields that are mandatory into that service. So as I mentioned, capacity, endpoints, start and end time of the reservation. Then when the NSI agent receives a request of any kind, so it doesn't need to be connection service, but any kind of request, he's going to understand what kind of service are you requesting from that, because it also can be, for example, a topology service, so he's requesting a topology update or whatever. So he's looking at the service type field, validate it according to its database of known service types, and if he finds matching types, like you request point-to-point service, he can read the message and he know how to map the information that is in the request. So he understand the capacity, he understand the endpoints, he understand any information that is in the request. For each of the service type, you have different attributes. So the mapping is required to understand the circuit properly. Then he forwards it to something like a calendar module or resource manager module, who can check if the request can be fulfilled. So if you request a 1 gig circuit and you don't have currently or at the reservation time the resources for fulfilling the request, you just send out back the error message. So it's the process of validation if the resources are available in your domain, and then if it's available, the resources are booked and the request can be forwarded to the neighboring domain. There is no limitation for the chain, so despite however domain there is, the request can be forwarded to the neighboring domain in a chain or in a hierarchical model. This is something called the NSI aggregator. I will talking about it a little bit later. The important thing here is that we can build a hierarchy of the NSI, so it doesn't need to be just chain. Not all domain needs to be equal in the federation. We can model something like as in the NordUnet case. So we have NordUnet as an aggregator, and the other NSI agent doesn't need to know there is some smaller NRNs at the bottom of that. He's just aggregated into one big domain and it can be interacted with other NSI agents. Okay, so that's more or less what Guy wants to say. I will go straight to the second presentation, which is we'll be talking about the things that we are thinking to implement in the future for the NSI, so things that is missing at this moment in the version 2.0. And after that, we will have a time for questions. So the second presentation is a little showing what we are thinking at this moment. What I will present here is not what is exactly on the roadmap of the NSI, but because we just finished the NSI 2.0 definition. The standard should be published some very quick time in the future. We already have some working implementation on NSI version 2. We really started thinking about NSI version, NSI connection serving version 3. So this is what we have in mind at this moment. We didn't order that in a very particular list and didn't define the exact roadmap for that. So this is more like a free thoughts on it. So this is the list of a brief list of features that we are considering that are, let's say, important for the development of the NSI, either from our perspective as a developer of the protocol, so stuff that is missing, also from the NRENs, so what the protocols needs to support in order to implement that in the production environment, and also from the end users. So the user wants to have a feedback on how the circuit is progressing, etc. So there is 8 or 9 issues that I will briefly go through one by another and explain what that means. Jerry, you may interrupt me anytime, because on some of those you may have a little bit better knowledge. Okay, so internal domain transfer feasibility. At this moment, we consider the NSI cloud as a domain, as a full mesh. So any STPs can connect with any STPs without any restrictions. In fact, we little restricted that for demonstration purposes with the VLAN tags. So we use the label type field describing which VLANs are supported in a particular interface. So in practice, the Pathfinder will allow to go from one STPs to another only if they support the same VLAN tag. There's of course some VLAN translation stuff, etc., but this is not something I will be talking to here. In general, this is the case. In what is really missing now is this is more related to the topology service, not the connection service at this moment. We don't have a mechanism to describe which STPs can really talk to the other STPs, because using the same VLAN identifier is not the same as being able to be connected. So we can have two separate switches completely not connected to each other, and they can use full range of VLANs, but in fact we cannot have a connection between them. Yes, Jerry?
Well, I was just going to say is that you really are getting into a lot of issues about topology and pathfinding here. It's not really NSI so much, because things like whether the VLANs can be cross-connected is a function of switching. It's also a function of whether you even have capacity inside the network to reach one another. Even if the switches can technologically do it, they may not have capacity.
Yeah.
Right. There may be policy involved. Right.
Yeah.
So the feasibility of connecting any two STPs across an NSI domain has a lot more to do than just whether those labels
Yeah.
are.
So the problem here is that with the current topology model we are using, based on the NML features, does not provide enough information to do the efficient pathfinding. So we are missing some things in order to do the path. It works 99% of the time, but there are some cases that cannot be mapped in the topology representation and may result in defining the wrong path. So it's impossible to implement it. It looks fine from a control plane perspective, but when we go to the data plane, we cannot do that. So you get a failure message, and it's fine if you get it in advance, so you have time to prepare a backup scenario. But if you get it at the moment when someone requested the circuit here and now, it's a problem with the delivering the service at the estimated SLAs. So that's a case. We don't have any mechanism that can support the Pathfinder with really providing the internals of the domain. So in other words, the abstraction of the domain is too much abstracted. So we see the domain at too high level to see the internals. And despite of the technology that is used, we don't know how to connect the STPs. A little bit of the optimization, a little bit of efficiency. There's a lot of stuff around that. Anyway, at this moment, we don't have that. We're discussing that. It's quite complex because it's more related to the topology service, and the NML people is a separate OGF group. So we need to have an interaction with them on how to deal with that. Okay, another issue is something that we don't have now is, we call it switching service. One of the features of the switching service, but not only one, is providing the multi-point connectivity. So switching service is some kind of a virtual switch within a domain that has its own STPs. The virtual switch is able somehow to split the connection or merge two connections into one, and to provide some additional managing mechanism for the particular circuit within a domain. So we can, for example, apply additional policies to particular switching point. We can apply some additional rules. We can do different kind of monitoring stuff, etc. So in one place, it adds additional logical layer to the circuit, to the connections that we can possibly use, and it also extends the functionality of the service itself. So it's not point-to-point anymore. We can do topologies, we can do some infrastructures as a service or whatever. The implementation of that is a completely different thing. It's very strongly related to the technology that you have inside your domain. To your network management system, to all the stuff like that. But at the very top of it, what we can see is that we can define something like the switching point, the switching service, that will be able to aggregate some services, some connections into some switching points that we can additionally manage and apply different rules for that. The switching service probably will be defined as a separate service. So this will be parallel to the NSI connection service because of the different specifics. It will use the NSI connection service, but not necessarily be the connection service itself. It rather be a separate service that will be extending this one. Jerry?
I would just say that these are all futures, right? So,
Yeah.
so we don't really know how these are going to roll out. In fact, the only thing I was going to point out here is that there was discussion just recently at the Glyph meeting where you could do the multi-point connections as just a a feature enhancement of the
Point connections, right?
Yep.
So on all these topics, as you go through them, just realize that these are just now starting discussion within the working group. So, there might be proposals for how you might do them, but until we actually work through them, it's hard to understand just exactly how these are gonna play out at the end. So it's gonna take a little while to sort through them.
Yeah. But from the practical perspective, this kind of service, by providing the multi-point connection, may be important for the NRENs while providing the services on the either locally and in their domain as well as for the global scale.
Yeah, at the end of the day,
I'm not sure it's gonna matter a whole lot how it's implemented, but at the end of the day, it's the feature that's gonna be available. Will be these multi-point connections, which can function, say, for like broadcast domains, for cloud services, right? Important aspect that we use, or for, in this case, these were brought up for video distribution networks. All right. So we need these types of connections. How we actually put them under the cover in the protocols and the semantics, that's still being worked out.
It's future perspective, and I think, as we see later, it's not looking at implementing that in near future. At least for the next 2 years, we'll do all the questions after the presentation.
Okay, availability query. At this moment, there is no way to check if the link is feasible to be implemented. So you need to request a circuit and get the real resource booked for you to get a confirmation that the circuit is possible to be implemented. So for the users who just want to check feasibility, if would that be possible if I want a 1 gig connection next week, is it possible to get it? Just to get an information, if it's feasible to, I can do the experiment, or I will not be able to do that, I can plan it or not. So instead of booking the resources and doing some RISE conditions, etc., we find out that it may be useful to have a availability query. So the implementation of that is not very complex. It's just check the resources, but not book them, and we can get feedback if the resources are available or not. But anyway, the availability query does not oblige the federation, the NSI infrastructure, to provide the circuit. Yes?
So if it doesn't come with any guarantees, what's it worth?
Yeah.
I mean, why not just reserve and see what happens? And instead of
I know, but there were some cases discussing during the NSI meetings that people wanted just to know if would it be possible to make up this connection or not, and doesn't want to make a real reservation at that time. They just want to check. So I have an experiment, and I don't have that at a fixed time, and I can try to check. Is it fine if I do it on Thursday? Is it fine if I do it on Friday? Is it fine if I do it on Thursday, etc.? But you don't do the real reservation. So the answer you get is you can do it either on Wednesday or Thursday. And then you can try to evaluate your experiment and then fix the time and request the real resources. I know.
You can actually try to reserve and then without committing, and everything will evolve by itself.
Yeah.
That's actually useful.
Yeah, that's pretty cool. But what we're talking about here is the implementation of that. What I mean here is that we're missing the features. So there is no query like that in the NSI at this moment.
What we're seeing here in this discussion is the fact that these are ideas that people put up on the list that they'd like to discuss in version 3. It may or may not ever hit the ground.
Anyway, that was repeated several times, so I think we probably will need to think about it a little more, and it's actually on the list what we should do.
What it boils down to is availability query is in fact topology processing. If you can look at your topology and see if something's available, then why do you need a query? Just download the topology and do your own process.
Well, it's a question how deep you're going to investigate your details, your resources. Is it just a feasibility, or you really check the resources if they are there?
A lot of these things,
But
as we go through this discussion, what we find out is that the use case that somebody came up with, like availability query, actually is maybe a special case of a broader situation where you say, well, all right, the availability query, why not just give that person the ability to look at the topology and make their discussion themselves? Because
because it's really much more complex. If you want to know when it is available, that's a whole different question.
Yeah, that's a very complex case for a
Right,
particular
so that's
question.
why I just caution everybody as you see these features come up. Radck's right that there were real use cases that sounded compelling. But as we go through and discuss them in the group, and you guys can follow this if you want to, lurk on the calls. What we oftentimes find is that, wow, we could do this simpler by just, a tweak here, or if we generalize it, we get a much broader set of feature capability with minor tweaks. So all these points are on the list. But how they resolve, how they actually will be implemented, in 9 months or a year as the standards evolve.
The question when I can do the reservation is something I did not put here because it's quite complex to implement. And as we discussed it, I don't think it will be in version 3 of the NSI, which will be in a year or 2 years from now. So this is really song of the future. And the real quick availability query is a completely different thing. We can easily implement that and put it somewhere on the list. So, okay, but still, the features I am talking about here are still under discussion. So this is not fixed. It may happen that availability will not be in any version of the NSI anyway. Okay, resiliency. Resiliency is a very urgent issue for the NSI at this moment. We don't provide actually any features for that. So, for example, if someone wants to have protected link for the reservation, the only way to do that is to request 2 independent services for that. But there are thousands of cases that it will not work because, for example, you have just one interface going in. If you want to request a 1 gig circuit and you just take the 1 gig interface, the second service will not be provisioned because there is no resources, etc. No, Jay, I know you can talk about it for years. I just want to put a very brief, to scratch a problem that we started discussing that to have an option to request the resilience features in the NSI request. And this is actually 2 levels of the resiliency, the intra-domain one and the inter-domain one. The intra-domain is, let's say, easy because it's up to the domain. So if the domain support the protection mechanisms, etc., you can simply use them. The problem is when those mechanisms needs to be escalated to the multi-domain environment. Like we have case here that I should number the STPs, but anyway, one of the STPs failed. So the domain is able to reroute the circuit using different STPs. But then you change the global connection. So you need to notify the neighbor domain that the service will not be available on the particular STPs. Now it will be on the different STPs. You need to check the resources or do all the agreements like a regular reservation, etc. So this is the mechanism that need to be supported by the protocol, all the information exchange and planning, additional pathfinding stuff, the protection or recovery mechanism, which works completely different, etc. We have at this moment no work done on this issue. We have some things, we have some draft, we have some ideas how it should work, but we didn't specify which will be included in the NSI and which will be focused on. I think so. Yeah? Okay.
So now can I add something?
Okay.
There's even some discussion when you're talking about resiliency. This is all assuming that you have redundant paths, right? The real question is, do redundant paths give you the resiliency that you need, right? So just quantifying how reliable you need your circuit, how many nines, can have a big input on these processes, right? So it might even work out to be that a network advertises that they have 6 nines reliability. And so for that network, you don't need resiliency. You don't need to do this redundancy thing because they provide a guarantee that you can rely on. Because you never have complete guarantee that this is going to keep you up, right? All you're trying to do is minimize the amount of downtime that you experience, right? If something goes out, right? So you as we go through, as the working group discusses these things, all these little nuances of why we would do this. This is basically an example of a kind of a bad habit you could fall into of just taking techniques from previous technologies, like sonic, protection switching, and you think, well, we just map that into this, and then you realize, no, we really don't need that. What we need to do is think about it differently. Do we really need protection switching, or do we need some way of quantifying our reliability? Right. So these questions come up in these working group discussions, and then we can address them in that fashion.
Let him finish.
So this is a very generic problem. I mean that by it involves not just the connection service, it also involves topology, because I need to know if those two STPs are really redundant. So if I route one circuit to this one and the other one to the other one, will they really be redundant, because they can actually, in the physical topology, can be mapped to the single interface, just to two different VLANs, for example, or two different kind of services implemented over that. So there is no resiliency at all. So the topology needs to support it in some way, then the pathfinders needs to support it. So if I request a protection, that it should use the different STPs as much as possible, so the different pathfinder algorithms, etc., etc. And this is something that is really needed, because if user wants to have resilient services that they can rely on, and we need to provide a way to implement that in the bandwidth on demand services. So this is one of the crucial points here. And of course, it requires monitoring. Monitoring is another important thing, because on the one hand, we want to know what's going on in the network. We want to know which resources are available, which are actually failed. We also need to monitor the quality of service or the availability of the service itself. So if you provision the circuit, I want to know if any of the STPs or domain have any issues with implementing these connections, or this is the circuit running as it should, as is expected. So we have then additional very complex thing which Jerry very likes, which is end-to-end performance of the circuit. Quite complex issue that we need to touch. So also the users wants to know how the circuit is operating. So for example, not looking far from here, Paul wants to know if the circuit I provisioned for him is really a 1 gig circuit, because he's gonna really put a 1 gig in data throughput to that. And I need to provide this information to him. If there's some kind of an issue, he cannot get more than a half of gig, then I need to know, and he needs to know that information. And without monitoring, I'm completely blind, as well as he is. Well, he has persona, so he's a better situation than me.
No, we don't have persona. We wrote our own testing interface within our NSI client.
Okay. So monitoring is important from different perspectives, and it's a must-have feature in the NSI. What we don't want to do is to implement yet another monitoring framework. Instead of that, we want to have defined some interfaces or some kind of a framework that we can connect other monitoring tools, other frameworks that is actually already developed, validated, and used by NRENs or any kind of the organization that is going to use the NSI. So like for example, Perfsonar or whatever, or Nagios, depending on what we want to achieve for the monitoring. So we need to have a kind of a plugins, adapters, whatever you call it, to adapt some existing monitoring solutions and integrate that with the features. So that influence a service as a whole, because there is a lot of aspect that is influenced by monitoring at this moment. Another thing is something called smart aggregator. So the aggregators are some kind of a special NSI agents, which has more features than the regular just providing agents. So they can split path into the segment, for example, and delegate the request to the smaller domain. So for example, at this figure, the NSI providing agents on the very left can be NRENs that are united under the NordUnet domain, and then the aggregator above them is the NordUnet NSI agent. So I delegate the request to the NSI agent in NordUnet, and he is responsible to delegate the circuit to the other providing agents, which I don't even know as a top of the tree. Yes?
How is a smart aggregator different from a normal aggregator?
I have the same question.
Yeah. What we are missing, it's connected to the previous slide with the monitoring stuff, etc. The smart aggregator is something that adds a little bit of intelligence to the circuit itself. So it reacts on failures, It can provision, has advanced pathfinding, providing the protected path, for example. It integrates the features that I was talking for the previous slides. So it's smart aggregated, it's just a name. In general, we want to enhance the aggregator itself, the features of the aggregators which are defined in the NSI version 2.0 standard, with the features that I mentioned before, to make it more flexible and to adapt to the situation that we have in the network. So it's just another step of the development of the aggregator itself. As the last point said, it doesn't change the protocol. It's the internals of the edges of the aggregators that enhance its features. Another thing or problem that we have is something that people from Ethernet faced, and they solve it by using the spanning tree protocol, for example. We can have loops in the hierarchy of NSI agents. So in this example, it's, let's say, safe because the circuit itself will be created. We have just one loop, but it's not continuous loop. But there are some cases that we discussed that we can have recursive requesting the NSI agents, and they're gonna go into infinite loop generating messages. And instead of creating the service, they'll keep talking to each other. It doesn't do much work. So we don't have any mechanism at this moment to prevent looping in the NSI agent. So we don't have timestamp, for example, in messages, or we don't build a spanning tree over them or any kind of like that. In general, in practice, we didn't have any kind of these situations in the demonstrations, but the demonstrations are prepared in a very specific way. So in the real environment, when we deploy the NSI agents and build it on the topology, it may become a real issue that the service will not be provided because the NSI agents start looping each other. Policy and AAA stuff. This thing is required actually by NRENs, by anyone who delivers services, the network services to the end users. We support it in a very, 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 very little way. I mean that we have only authentication at the level of NSI agents. So this is a trust relationships. I know who you are. There is not actually any kind of authorization implemented. There is no policies at this moment, etc. Yes.
So the way this is defined in the NSI protocol is that it's via SAML assertions, that is in the header, it's in the standard now.
Yes.
And that this has been put into that this is something that has to be negotiated between control plane peers, and there will be a best practice in an appendix, but it will not be a part of the core NSI standard.
No, it will not be, but we need to have some hooks to support the authorization, and also the policing, because...
But this is not up to the NSI group, this is up to the one
Yes,
that operates.
yes, but we need to have hooks. We need to be aware that there is some authorization authentication process going on somewhere. Yes?
Which means therefore that in this group we can start with something and have free hands to some degree, as long as we communicate those different groups. So.
Okay, so anyway, authorization, authentication, that's fine. Accounting is, as I said before, the monitoring is required to do that, to collect information on what's going on in the network, what circuits, how many resources, who's using what resources, etc. Also for billing users, I'm not meaning explicitly money here, but to know which user is using the network at which level, so we can make some policies, for example, or prefer some users. I don't know, any kind of a statistic. If you have a EU-funded project, then you probably want to provide some very nice looking statistics to the commission at the review. So it may be also useful for that. Okay, so priorities are at this moment, because it's still fluctuating and we change the concept every meeting. In general, the main two important things at this moment is monitoring and connection resiliency. Those two things will be discussed in most extensive way. So we need to get into deep of the problem, define the solutions, and provide the extensions to the NSI protocol specification to support those things. The three another things in the queue is availability query, which is not very complicated to implement and may be useful for some people. Internal domain transfer feasibility, so that this is the topology model related things, and the switching service, which is a little topology and little the NSI itself. Those three things are less priority, but there's also in scope to keep that into NSI version 3, for example, or somewhere in the future. The policy AAA is not necessary the protocol itself. It's still important, so it's still on the list, but it does not influence the protocol itself, so it's not so important for us. The smart aggregator is just the extension of the functionality, so we don't pay too much attention to that at this moment. And as I said, the cyclic, the looping of the NSI agent is also not critical at this moment because we didn't face the real case that in the production environment or testbed environment, we didn't face that issue yet. So it's we treat it a little marginal at this moment. So we know the problem exists, but it did not happen yet in the environment. Yes.
Since you reserve resources in each request, or at least you should, unless you're just acting as a proxy, you will actually bottom out in your reservation phase at some point.
Mm-hmm.
Unless you get into something where you don't reserve resources.
Yep.
So, yeah. So, I don't think it will be a problem.
When I look at the list and look at things that are needed to move data for demand to a production environment, things that are really critical for doing so are low on that list.
Yeah, but
that is smart.
That's
certificated.
yeah, that's
And
because
I understand that for the NSI
yeah,
group.
this is from the NSI perspective, and this is because this is not necessary, the specification of the protocol. So the policies, AI, etc. It's not the NSI itself. It's the additional services that we just need to collaterate or join together. The smart aggregator does not influence the protocol itself. It's the features of the aggregators. But the NSI agents are actually developed by NRENs. So what we as the NSI group provide is just the protocol definitions, WSDL file, and standard as a protocol. And then the NRENs develop the network management system with the NSI implemented. So in fact, the smart aggregators are almost there. It's actually up to you if it's going to support that features or not.
I partially agree with that. Looking at the smart aggregator, one thing that's needed there is to agree on how to describe topology, how to, and you already mentioned that, how are we going to do VLAN swapping, adaptation between different service types.
Yeah, completely
it would
agree.
be very handy to have one place where this kind of things are being discussed, and the NSI working group seems like a natural place to do so.
Yeah, of course. All the list here is actually important because this is something that we discuss and find. Yeah, it's useful.
Okay.
The priorities here are some way my subjective way of seeing that. Okay, so the biggest problem for now is monitoring and resiliency, which resiliency especially is quite complicated. So it takes a lot of effort to agree on how to do that, how to exchange information. For the AAR or smart aggregating, there's less work to do. So I put a little down on the list. I got a feeling from the meeting that this is more or less the order that we want to put the stuff. But this is not fixed. We just have 1 or 2 meetings discussing these things. So still there is a lot of discussion how to prioritize them and what focus. There will be a working group focusing on different things. There is another issue of integrating for example, the NSI connection service with reserving the other type of the resources at the same time, like cloud computing stuff, booking the CPUs, cores, memories, etc. in one request, and also with the network itself. I didn't mention it here because it's something like a parallel service, but it also was discussed. There were several other ideas that we also discussed, and they are not on the list. So this is just the most important things, and those most important things were then even more prioritized on the top. So we didn't forget about the aggregators. We know that there is a lot of work to do, the exchanging information, agreeing some stuff. We know that there is a framework, but this is how I see the work that will focus in the next few months or a year on the NSI working stuff. It will be done in a parallel anyway, because there will be working groups that deal with the problem. But the scale of the problem is, for example, for monitoring or resiliency and for just marginal, let's say, problem for looping the NSI agents is a completely different. So the balance of the efforts required to solve the problem is a completely different thing.
Any other questions?
Okay, thank you very much.
You guys can eat that. There's a non-less way of saying welcome. But no, you can eat that. And if you want, if you look like a barrel, you should have sweet
Okay, so now the third and final presentation for this session. I will present you with how Autobahn implementation, the giant implementation of BOD is progressing, and what are our plans for testing and migration of our new Autobahn version to production. This presentation actually fits quite well with what Radck has already described, and I will try to explain what are our thoughts for filling in some of the gaps that were just discussed, things that are not specified in the NSI protocol, and how this should be handled for the time being in Autobahn in order to achieve an efficient production service. So I will go through the changes that we have done in Autobahn version 3, which is the version that will be fully compliant with NSI 2. And I will describe what are the modules of the old Autobahn that were heavily affected and rewritten, and which modules were not. And then I will go over the benefits that Autobahn has gained from incorporating the NSI standard, and some of the considerations or things that are not yet finalized in NSI and are left for NSI version 3, but nevertheless Autobahn as a tool that is deployed in production needs to somehow handle. So this presentation will be very open to discussion, and your feedback is much appreciated, so you can interrupt me anytime to ask questions or comment on the things that I present. And then finally I will go through the testing and the migration plan and the timeline that we have, which is also related to the promises, the contractual promises that have been made. So this is a reminder of how Autobahn is structured. This is the version 2.4, the latest stable version that is deployed in various NRENs right now. So Autobahn is structured, a single Autobahn instance is structured in a few basic components. We have the IDM, the interdomain manager, which communicates with the other domains. We have the domain manager which handles local topology information, which information is retrieved by CINIS, an additional module attached to Autobahn. And then configuration instructions are actually prepared by the technology proxy for configuring the underlying devices or the NMS. And there is a web GUI, the BOD portal, which has access to all IDMs, and also a lookup service which in Autobahn 2.4 is used for mainly for exchanging topology among the domains and some other secondary purposes. So now we are in the process of rewriting Autobahn, and we are preparing Autobahn version 3. Just to let you know that Autobahn version 2 is already deployed in several NRENs, as you all probably know. So there was a decision that version 3 should go native with NSI version 2. And this meant that we had to rewrite the internal state machine so that it goes according to the NSI specification. And we also replaced the inter-domain communication protocol among the IDMs in order to be compliant with NSI version 2. Here's an overview of how NSI version 2 handles the reservation processing. It actually defines 3 separate state machines, all of which are simultaneously active at a single, for a single reservation. And their purpose is to simplify the amount of all possible states that can exist during a reservation processing. Because as we will, I will also later talk about, NSI supports a lot of things that Autobahn did not support, such as reservation modification or the possibility to provision and release the data plane at will. This compared to the old Autobahn state machine has several important changes. This is slightly internal information, but I go over through it because it, at some points it also appears to the end user. There is some of that that has that affects the way that the end user perceives the service. So how Autobahn used to operate until version 2.4 is that it also had 3 state machines, which were called home, external, and last domain. But the difference was that for each reservation, only one of these state machines were activated. And the reservation processing in Autobahn was done in 2 stages. There was one forward progressing stage where the reservation parameters were transferred from one domain to the other along the inter-domain path. And then there was a second stage where the reservation returned backwards and it was actually booked at the domains along the path. And for users of, for current users of Autobahn, these may be familiar states that are actually also displayed at the BOD portal. So for example, reservation was either an accepted state when it first started, then there was inter-domain pathfinding that determined the domains that will participate in a given reservation. Then we had the local check phase, where actually the reservation was transferred from domain to domain, and the important thing is that this also included a gradual gathering of technological constraints for the reservation. So when we reached the last domain of the inter-domain path, we could be aware of exactly what VLANs, for example, were available in each domain, for which time periods, whether VLAN translation was available at some important points along the path, and so on, which allowed the last domain to actually determine and pin down the parameters of the circuit, like for example, which VLAN should be used or where VLAN translation should take place. And then the reservation returned backwards with the specific constraints that were decided, and each domain booked the reservation in the scheduling and then scheduled phase. And of course then we had the activation states. I go through this in some detail because this will not exist in Autobahn version 3. So now, according to NSI, the reservations will be processed in a single stage. Okay. And the second major change was that inter-domain communication, of course, now uses the operations defined by the NSI connection service protocol. So we have basic operations like reserve commit, provision and release, terminate reservation, and query operation. And another major change is that with NSI, the topology, as Radck also described earlier, is not the abstract topology that is exchanged between domains is now simply a set of STPs and STPs. So the abstract topology right now has no concept of the internals of a domain. Whereas in the previous version of Autobahn, the abstracted topology was a little bit more complicated because it also defined some virtual nodes, some virtual links, and some virtual ports, which allowed to support what Radck described earlier, the possibility of having two STPs within a domain that are not necessarily connected through some internal path. But this shows that Autobahn will follow the discussion that is currently taking place within the NSI working group. And of course, we will try to keep up with any improvements in that area. What has not been changed for NSI version 3, for Autobahn version 3, is that there are no changes at CNIS level. So the way that intra-domain topology is represented, and this means that existing deployments don't have to do any work related to their topology representation in CNIS. The interface towards the technology proxy also doesn't change because it's not related to NSI. So again, this means that technology proxies currently operating will remain as they are. Then, although we used to have the user access point and administration web service interfaces for requesting reservations, and these interfaces are replaced by NSI, we will actually preserve some backwards compatibility for a small subset of the methods that are currently in use by clients, such as Bonfire and OpenNAS. And internally, Autobahn will do the translation of these incoming operations to the NSI core. And also, the domain manager, to a large degree, remains unaffected. There are some changes in the domain manager, but things like local authorization policies that were already supported in Autobahn will remain the same. And this means that what Autobahn also currently supports, it will still allow, it will still be able to, for an administrator, a local administrator, define some local policy and have his own domain, for example, allow or deny requests based on whatever combinations of user attributes are desired, like user email, user organization, user project, or user role, a set of user attributes that we currently define for users.
So,
yeah.
That very point about you can allow or deny requests from external users, I mean users from outside your domain. That is already a feature existing.
Yes, yes.
Keep existing.
Yes. It's somehow affected by the way that the AI policy will take shape, of course. But this is, let's say, an independent functionality that can allow you to put some local policies on the user tokens that you receive, on the various attributes of the user that, on behalf of whom a reservation is submitted to a domain.
I think it's a selling part for people, for end-to-ends which are afraid that they should accept any kind of request without any possibility, the very possibility to limit some users they don't want. Anyway, so that's why I wanted to underline.
Okay, so later on I will go into more detail on what migration steps will have to be taken, but for the time being this is some of the things that currently exist and will not be affected. So now moving on to what benefits are gained from transition to Autobahn version 3 and the support of the NSI protocol. These are a list of things that of functionalities that Autobahn did not support, and it now does because they are supported in NSI. So the first bullet is something that was actually touched upon by Radck. In NSI we have a reserve and reserve commit. We have two different operations. So you can reserve, you can make a reservation. This goes on to all the domains that are needed for this circuit to be realized. Resources are booked, but unless a subsequent reserve commit is done, this reservation will be automatically timed out. And this is sort of a functionality that allows someone to try the feasibility of reservation without actually committing it. So I think this is what was discussed earlier and what also Henrik raised, that NSI already supports this sort of, let's say, availability check. Another major thing that is supported by NSI is, of course, modification of reservations. So you can modify start or end time of the schedule of your reservation or capacity. And of course, the major benefit is that there will now be effortless peering with other BOD participants who have their own systems, as long as they support NSI version 2, which is already very widely implemented. Whereas currently we had to have adapters for IDCP or adapters for NSI version 1, and there was a mismatch between the state machine at the other domain and the state machine within Autobahn. So this was far from ideal situation, of course. And another new thing that Autobahn did not have and was actually discussed during some previous workshops is the capability to have both automated and manual provisioning. The way that Autobahn worked until now was that the user requested some reservation, and assuming that the reservation could successfully be booked, then this reservation would go on and would be activated at the data plane no matter what. Unless, of course, the user went to the portal and cancelled it, or some administrator went in and cancelled it. Now with NSI we have some better flexibility in this area. Because right now for reservation to actually be to become active at the data plane, for the circuit to be configured, there is one additional message that has to arrive, which is the provision operation. So even if, for example, a reservation start time has arrived, the data plane will not be configured until the provision message arrives. If the provision message arrives before the start time, then this means that at start time the circuit will become active.
Excuse me?
Yeah.
I think you only get the provision confirmed at the start time, not as soon as you send the provision request.
Yes.
You get provision confirmed immediately back. You get a data plane changed message once the
Not if it's before the start time.
That's a big difference between NSI 1.0 and 2.0.
Okay.
So the idea is that this is called automatic provisioning, and the idea is that if the provision message arrives before the start time, then a timer is set, and at the start time the circuit will be configured. This is the idea. It's not that it will be configured at this, but you will just get a provision confirmed back, and then at this moment the circuit will be in service. So this allows several use cases, like for example having an administrator be responsible for confirming the circuit and sending the provision message. Or we can also have multiple cycles of releasing and reprovisioning the circuit. So the resources remain booked for the whole duration of the reservation, but the actual data plane may be in service or not, depending on whether a provision message has arrived or whether a release message has arrived, which removes the configuration, and then later on a provision may arrive again, and so on. So this gives a lot of flexibility actually in terms of how the user perceives the service. I don't know if Victor, I saw him that he was with us a while ago, but because they were actually the ones that had requested such things, for example, in the past. But it seems that unfortunately he may not be with us now.
You still have 3 or 2? Oh,
Okay.
on the phone also.
Hi, Victor. Sorry, Jan, what was the question?
There's also 2 on the phone directly without video.
Okay.
Would be one of them.
Okay, sorry. So I just mentioned the Janet because I remember that in past workshops there was this feature request, let's say, that the capability of an administrator should be there for him to remove the configuration or do not allow the configuration to take place at all. Okay, so now some considerations, some things that should be noted, or some things where we will lose some functionality because of the migration to Audubon version 3. First of all, one thing is that the existing peerings that we have will not be migrated. So there will not be an IDCP adapter anymore. There will not be an NSI version 1 adapter anymore. So the only possibility, at least in the first phase, let's say, will be that only other peers who also have their own NSI version 2 implementation will be possible to interoperate with them. Then there are some features that Audubon used to have that do not exist anymore. For example, Audubon used to have the concept of service bundles, which allowed someone to request multiple reservations at once and have the software treat them as a single entity. So the software would either provision all of the requested circuits or would not provision any of them. Yeah.
That was actually a feature that had been considered, that was discussed as part of version 3 for NSI. We didn't call it bundles, but,
Yeah.
but the idea of being able to submit, a request that had multiple connections in it and have them work as a group. So don't be surprised if that shows up in V3.
Yeah. Actually, to be honest, this was one of the features that was not used. I don't know, or it was used very seldomly in Autobahn. So it's at least from a practical point of view, it may not be a big. It may not be missed that much. As we heard Radck describe earlier, of course, NSI version 3 also has plans, at least, both for service bundles or switching service, which is, of course, a slightly different concept, because there we have point to multi-point connections. But in general, these or similar features may reappear in some time when Autobahn moves along with NSI version 3. Then we have the various problems that were already discussed during Radck's presentation. One feature that we had in Autobahn 2 was that you could leave the VLAN selection to auto. So if you did not care which VLAN would be configured, but you just wanted to have a circuit and then let the software inform you about the VLAN that it could be able to provision, then you could do it through the BOD portal, for example. And because of the way that reservations were processed in Autobahn, we were able to gather the available constraints at the last domain of the path and then configure the rest of the domains appropriately. This cannot be efficiently done in the current implementation. And in general, inter-domain pathfinding will not be optimal too. I understand that NSI version 3 plans to somehow deal with some of these issues.
Can I make a
Yeah.
couple of comments?
Mike.
Just the issue about pathfinding, we've run across this a number of times in NSI since we've started, is a question of if you're pathfinding from an outside agent looking at all these different domains across the globe, how much information will you have about what's happening inside those networks in order to make a decision about how to transit those networks or which networks to transit? And that's a very hard problem. That requires a lot of real-time state information that, frankly, I don't think most networks are going to announce or make visible. So the issue about pathfinding boils down to you either have an external agent that is trying to make these pathfinding decisions, or that external agent can go to a network and say, here's what I require. Can you give me a path that does this, right? And let the local agent do the local pathfinding. I'm personally more in the latter school. That says you let the local guys do the local pathfinding and you abstract that up so that the high level global pathfinding is very, very, very cursory. But not everybody does that, and some people would say, well, you're not going to get optimal paths if you don't see that visibility and have that global view. But the fact of the matter is, global optimization is not one of our goals, frankly. It's making that user request succeed, right? Mm-hmm. That's really what the objective is. And so a lot of this pathfinding stuff where they're trying to find optimal paths, it's just it's a never-ending battle that you're just not going to win in a pragmatic world.
Yeah. I agree with this. Of course, it's a very difficult problem, and Autobahn was also not optimal, of course, in this area too. But there is also the secondary, let's say, issue of assuming that you have selected the domains, you have selected the inter-domain path. Then there is the issue of being efficient in finding out whether for this specific set of domains, you can actually make a reservation or not, depending on the constraints you have by each domain.
But see, that's exactly what I was talking about, is that you don't know what the state is. You don't know what the state is inside each of those domains.
Yeah.
And frankly, most of them are not going to tell you that state, or it's going to change so quickly that any sort of announcement you get is going to be out of date by the time you process it. So the fact is that there's an atomic process where you have to go through and say, this is what I need. If you have it, lock it for me, reserve it, right? And then tell me you have it or don't. And that's where we keep falling back as a community. We keep looking at these problems thinking that somehow or another there's an agent out there that can see and tell everything, and that it's the only agent doing this. Now you've got 50 different agents out there trying to get that same piece of of network, right? You can't look at that state, and wait 30 seconds before you reserve it. You really have to lock it when you look at in that atomic process, and that's what we keep tripping over. And I think we're going to continue to do that until we just say, look, we don't need to optimize this stuff. We just reserve it, get what we can, and that's what you have, right? There's very few situations where the users need to optimize any sort of path. They may like minimum latency, but that's one of these elusive goals too, because at any given time, given the state of the network, the same request can generate different results, different answers.
Yeah.
And so minimum latency at any given time is going to be different.
Yes, I agree, of course. The way that Autobahn used to approach this problem is that the previous version of Autobahn, is that it did not make an effort to have an optimal interdomain path, but still, because of the way that the reservation was processed, it was able to gather some constraints. So it actually took some information from each domain as it was processing the reservation. It did not have this information acquired at the previous time or whatever, or at some external agent, but the reservation itself, the reservation token, was gathering some internal information. So at the end of the path, you were able to make a more informed decision and not with the aim of improving latency or whatever, but mainly with the aim of improving the success rate, for example. So you could do some clever VLAN translation at some point and be able to build a path even if a VLAN was not available across the whole.
So this brings up a question that this workshop probably should keep in mind also, is that a lot of times what we do is we try to reflect the hardware that's out there rather than thinking, what is it that we want the service to do, right? For instance, the VLAN translation issue, we constantly trip over this. And we think we have to go and figure out whether or not we can do VLAN translation. Baloney. Just put the freaking switch in that can do VLAN translation, and you've got a scalable solution, right? It costs almost nothing to do that. And if you have a switch that can't already do VLAN translation, you've got some old piece of crap, to begin with, right? The fact is that we should be engineering these service domains to do what we need to, not the other way around. We shouldn't be trying to develop signaling protocols that simply reflect the sad state of affairs we might have in terms of this type of switching capability. If we need scalable switching technologies, let's put it in place, right? We can do it with Sonnet, we can do it with ATM, you could do it with MPLS switching, right? And all that can still carry the VLAN framing, right? So it's very easy for the users to actually put data in and out of it, right? So we need to stop thinking about this hardware as how do we reflect the limitations of our hardware so users can see that. What we need to do is decide what is the service we need to provide that makes this efficient and useful for users, and then engineer that into the hardware and make sure that that's available, right? And forget about trying to recover all this, these these flaws that we may have in the hardware, right? It's just I don't. It's very frustrating to see us continually dealing with that issue.
I'm just going to stay here.
No, I just wanted to emphasize what Jerry just said, that it's we should focus on what the user wants and not
What the
what.
user wants and what we need as a service technology.
Yes, exactly.
Yes. Facility. Don't focus on what you have.
And also over-engineering. I mean, you can spend a lot of time optimizing stuff for the last bit, and that's not what we should do. But I guess Kostas agrees on that as well. So maybe you're put in a corner there. But
yeah, I'm just okay. I'm just trying to point out mainly to, let's say, existing users of Autobahn, what we're going to lose, let's say, and what we're going to gain.
Yes.
I mostly agree with Jerry that perhaps what we're going to lose is not so important, and if we have some equipment that supports VLAN translation along the path or whatever, our lives are easier, definitely. Okay.
I think even the whole issue of VLAN translation, you're focused on one particular little technology when you have a lot of different choices of how you could do this. Right? And we're just now we're all of a sudden focused on Ethernet. Right? We need to step back from that and think about what it is that we're actually trying to deliver to users. It's not typically Ethernet, right? They just want to move bits. Ethernet is probably the easiest way for them to do that, but that's just one possible scenario.
Okay. So again, in Autobahn, we used to have the test reservation functionality, which was some sort of an availability query. Now this is replaced currently with the reserve and reserve commit sequence, which may probably, in my opinion at least, be a better solution, because test reservation had various issues because it did not actually book resources. Whereas when you do a reserve, you know that your reservation is booked, and then you can commit it and be sure that it will be available to you. So as I said, the domain manager has been adapted to the NSI operations, which means that several modifications need to take place there, like remove some of the timers, because this timer stuff is now handled at the NSI level, or add the modification operations, or support the multiple provision and release cycles. Also, the way that internal topology is abstracted, it's now abstracted to STPs, but not the abstract topology is not internally represented as in the NSI NML format. So I will show later how there is an external module that does this translation. And we have kept the capability so that someone can create an API client and do requests to any NSA in the service.
you have more than one NSA in your service?
Yes, because right now Autobahn is deployed in Giant, in HCINet, in Janet, so each one of these would be a separate instance.
Do you have a slide on architecture later, or because this is actually an important point, like the last point you on the previous slide?
Yes, I think.
Yeah, okay, you do.
We will discuss this here.
Okay.
Okay, I will go through these slides very quickly because perhaps they're not so important. So we have modified the BOD portal to support the various operations in NSI. For the time being, the user does not perceive the difference between a reserve and a reserve commit, because the portal, the software is responsible for auto sending a reserve commit. in order to mimic somehow the way that reservations were handled in the old Autobahn. So a user made the reservation, and then he expected that no other action from him would be necessary. But of course, this is a very minor change, and it depends on the requirements by the NRENs or the users. So if they would like to somehow have this functionality of reserving and then auto timeout and then reserve committing a reservation, this is a very easy change to do at the portal level. And of course, API clients have full NSI CS access, so they can reserve and reserve commit as two different separate operations. We have also done the preliminary thought of changing the way that the portal connects to the various NSAs, and instead of having it connect to any NSA, connect to a single, let's say, root NSA in our cloud, which would typically be the giant instance, and then have this giant instance forward requests appropriately. This is again something that is under discussion. It's mainly an implementation choice, and the purpose is to have more efficient communication with the portal and an easier time setting up some policies or retrieving submit reservation and reservations and so on. And also we have added the capability, which was not there previously, to have multiple instances of the BOD portal.
The benefit of that is for multiple languages, or?
Yeah, or another thing that we observed a lot of times in the past during deployments was that some new domain wanted to come to the service, and they wanted first to have their own portal with which they could play around, and then we had to transfer them to the official portal. Whereas now we could have also a secondary portal, let's say, that would be only for usage within some domain or whatever. So the portal will now be an equal client like all the others, whereas in the past the portal was somehow a preferred client or a privileged client, let's say. And we could only have a single BOD portal in the past. So we're also creating a portal based on HTML5 to support automatically mobile version and also a possibility through smartphone application. One thing about how we exchange our topology right now between Autobahn domains and with domains outside and domains that do not that are not running Autobahn. Right now we have our own, let's say, Autobahn topology service, which interfaces with the domains that will deploy Autobahn version 3 and understands the topology as STP objects. And then this topology service is responsible for connecting to the global NSI repository, which is currently at GitHub, and upload topology in NSI NML format, or download topology from other domains like SurfNet, like Internet Tool, like NordNet, or whatever. And then the Autobahn domains can retrieve the topology as Java, as STP objects from our Autobahn topology service. And the reason we have done this is because the topology exchange is not yet finalized. We have tried to isolate the functionality at this level and not have to do any changes below when as the NSI topology exchange mechanism evolves. For existing Autobahn deployers, this this will be something, let's say, similar to what we had with the lookup service. So this is now called Autobahn topology service, and it can send the topology further upwards. Yep.
This is not this is not completely true anymore. The topologies are no longer all centralized on the GitHub repository, but the GitHub repository has a master file that lists all the domains with a URL per topology, and that URL may point to a file on GitHub, but NSAs that support dynamic topology creation, like OpenNSA or the BOD software from SurfNet, it will point directly to the NSA that will serve you the most up-to-date topology.
Okay. In any case, this does not change, I think, the concept here, because our concept is to somehow abstract all the information about Autobahn domains in a single instance, which we can update according to how the global exchange evolves. So I think this still applies in this case. Then a very central point is how actually multi-domain reservations are supposed to be handled. In the NSI standard, you're allowed to choose between a tree model and a chain model, and these are the figures from the NSI standard, which show how you could have a reservation by some root NSA that distributes it to its children, or whether you could have some sort of chain processing similar to what Autobahn used to have. In practice, I think the main restriction we have in choosing one of these models is how the various NSAs are restricted in terms of firewall configuration. So, for example, assuming that we would have that any NSA could talk to any other NSA is subject to scaling problems. In our current deployments, we have the giant instance, which has open firewalls to any other Autobahn installation. And typically, we also have open firewalls along the data plane. So if two domains have some data plane some data plane link that connects them, this will probably mean that there is also firewall an open firewall between their control plane instances too. So we are still not we have still not finalized how we're going to work with the various domains in Autobahn, whether we would have some domain that could be giant in practice that would operate as root. Yeah.
Oh, I just had a question about you talking about the giant acting as a tree root, right? But then you need this intradomain calendar required. Why do you need that? I mean,
okay, this is related actually to what we were discussing before regarding how to be able to take into account some local constraints when we decide on the path. So when we in the process of trying to think about how we could replicate the existing functionality in Autobahn, one possibility was that we would keep some sort of inter-domain calendar information in a root NSA that would thus be able to somehow simulate the way that the reservation processing used to take place in Autobahn version 2.
well, so the way NSI would do that is that you would have the root NSA that would have its own calendar, and it would segment the request out to the other domains. Then it would issue those requests to those other domains. Those other domains would also have a calendar, right? And they would make their reservation. But so the fact is that if everybody has their own calendar, the request, as long as it transits the tree according to the NSI rules, all the calendars should coincide, right?
Yes, but this would be a way to, let's say, increase the success rate of the reservations, because, for example, the interdomain calendar could keep track of what VLANs have been reserved in the interdomain STP between the two children NSAs, for example, and would be able to send a more specific request to its child and avoid getting a failure back.
Yeah, I think you're still coming up against the same question. How do you get that information and keep it current, right? I
know that our previous discussion somehow invalidates the need for this, but
it's worth thinking about. But at some point, you realize that having foreknowledge of what's available means that you're exposed to that information being stale, right? So the only way to get current information is to actually go out there and reserve it when you look, right? And have the local guy check and then reserve it if it's free, right? And then you come back and you have it. And if you want to increase your odds of success, what you do is you specify as few constraints as possible, right? Instead of saying, I need this particular VLAN, you just say, give me any available VLAN, right? And then the local guy decides, right?
But if the local guy decides, then this means that you might not be able to match the VLAN that he decides to provide you with the VLAN that the other guy decides.
Why not?
Find an NSI solution to that and not build something within Autobahn that only works within Autobahn and does not work as soon as you leave Autobahn again.
See, this is where we get into things like scaling architectures, right? If you use the notion of VLANs as flat Ethernet switched architectures, right, you're going to screw yourself, right? They're not designed for that. You need that scaling of say an MPLS label switching, right? That only uses link local tags, right? And so if you have a domain that does VLAN translation, you essentially solve that problem, right? It doesn't matter which one he chooses because it'll be the same next door and you can swap it and there, right? And so you can start with any VLAN and you can end on any VLAN and each domain along their switches, right? It's only when you start putting these constraints on there saying, I need this specific VLAN or this domain cannot swap VLANs, everything's flat, that you end up with these corner cases that make pathfinding exceptionally hard and exhaustive in terms of trying to find paths through there. It's very difficult. That's why they call it a local area network technology. Right? It just doesn't scale very good in a wide area.
Okay, if we make such an assumption, which I'm not against it. It definitely simplifies. And again, yes, we are aware of the problem that Paul mentioned, that if we engineer something Autobahn specific, then this will break as long as we need to make to transit to a non-Autobahn domain. So I guess this.
Can I ask something?
Can you speak to the chest of Kostas?
I'm coming.
Yeah, that's fine. When you say transit Géant could operate as tree route, does it mean that it becomes a requirement that Géant is chosen as the tree route? Will you support more than just chaining?
Practically, it's the one domain in our deployments that I can think of as operating as a tree route, because right now the situation is that we have 6-7 domains who are all, or as long as they come into the service, they open up their firewalls towards Géant, which also hosts the BOD portal. So it's some sort of a central location, let's say. Whereas having some other NSA operating as tree route would first of all bump into firewall restrictions, which and as I mentioned before, I don't think we are able to assume that we will have full mesh control plane connectivity. That would not be scalable.
You could also ask how many NRENs have problems doing VLAN translation in the network. I mean, anyone around?
I think
I'm not sure.
most NRENs now have sophisticated enough equipment that they can do that.
Yeah.
One way or the other. Right?
Yeah.
The other thing I was going to say about Kostas just quickly is that the control plane topology, there is a way now to reflect that in version 2 within the NSI Express topology. So you can tell which NSAs are willing to talk to one another, right? And then the user can, or an aggregator can determine how best to segment and which other NSAs will be able to talk to.
Yeah, but I agree, but the reason I point this out here is if we build this into some sort of, let's say, requirement that everyone has control plane access to Giant, for example, so that we are able to have Giant function as a tree root, and not something that could be, could or could not be true.
That's perfectly fine. That's common practice. I mean, that's something that this group could get together and say, well, for Giant, that would make sense, right? Or at least that would make sense for now. Have a central NSA that everybody goes to. Now, there may be other people like in SurfNet who are going to tell their university, no, you come to us first, right? Right? And you can't stop them from doing that. But maybe for the NREMs, getting to each other, you could pass it through one. But the real problem is that you can't force that on anybody. They can only electively adopt it. Right?
We have a clear requirement from some NRENs that, for example, for API access, I mean for clients, that it doesn't go centrally always. That you can do it, that a project in Ireland uses the API to HNet's NSA, for example. That's one of the scenarios that people prefer, and I understand the reason for that. So we need to be able to deliver that.
In that case, that would be, let's say, a request coming to a single NSA, right? Because if this request requires STPs from various domains, then someone would have to handle the aggregation of the request.
I think Victor Oliver has a question.
Yeah, I'll try. Can you hear me?
Yes.
Yes.
Okay. Well, I'm going to carry on with the VLAN translation topic. I think until recently, or maybe it's still the case, Autobahn and all other bandwidth on demand implementations, they ignored the fact that generally the normal practice of service providers is to impose a new VLAN ID on top of customer VLAN ID service, so-called service VLAN ID. And Genet practice is, Genet is a multi-domain network. So normally we push service VLAN ID on top of customer at the border of the first our regional network, and then on the border between regional network and the core network, or between two regional networks. So we follow Mitra Ethernet Forum ENI specification, which means that we don't strip off the service VLAN ID, we just or translate it or just accept according to some preliminary agreement between our domains. So this double-tagged VLAN technique was one of Genet requirement for Autobahn, and I think so. I'd like to hear what's going on in this area.
Thanks, Kostas.
Okay, this is one of the things that we haven't touched upon yet. So, and I think if we need to handle this, this will have to be handled in a way internally for Janet. To be able to know of the double tagging that takes place in the domain and support it in possibly support it in CINIS and be able to represent it within Autobahn.
But I think we have generally a clear idea expressed several times already by Jerry and several people that you should have some kind of subsidiarity. Keep it local, get the other domains to know what they need to know in order to get the service they ask for. And the rest is internal as much as possible.
Just a question, maybe for Jerry and Henrik and some of the other guys. I mean, double tagged VLANs. Is that something that needs support in NSI, or should it be kept local?
Comment,
Yeah,
Henrik, is that the whole issue of Ethernet as a switching technology makes it really bad because of one other thing is that it floods these MAC addresses at every switch, right? So what Victor was referring to was some of the, I think the PBT, I forget what the new standard is for that, but I think it's AH or something. But it's provider-based bridging, right? You know, so it puts the user's VLAN packet inside a tunnel, so that none of that MAC address flooding occurs, none of the VLAN conflicts occurs. And the provider's infrastructure is separate from what the user sees. You don't have that with the Q&Q, right? That's why they went to AH, right? It does a better job of that. But you can also do the same thing by stuffing the Ethernet frames into an MPLS LSP and just switching that. That now curtails all that MAC address flooding. So there's several issues that come up when you start talking about Ethernet as a framing versus Ethernet as a switching technology in these, right? So all right to use it as a framing technology where you hand a packet to the provider, right? But don't assume that is going to be what's used to switch it, you know, through the network, because that's a less desirable.
But the question still remains, I guess, that Janet has this problem that their internal network encapsulates client traffic in a VLAN, and if they want to, send that to the rest of the world, that original client VLAN will still be there when it reaches the end of the tunnel.
What is the provider carrying, the outer VLAN or the inner VLAN, right? If he's carrying the outer VLAN, then whatever's inside that should be carried along. Transparent.
So, but then the problem moves to the receiving end where they should strip that VLAN.
Yes, they're gonna pop it there.
Okay.
Yeah, so it's, I agree with Jerry that we should not expose this inner thing of what happens. I mean, you get one thing out and you get one thing out or in. I mean, what happens in between? I mean, in NortonNet it's MPLS, and in HereNet it's going to be carrier Ethernet, and somewhere else it's going to be something else. It does not matter how the packages get transported internally. It's just what you get in, what you get out. Unfortunately, HereNet's model is a bit convoluted to NSI, but it can be done.
Well, I think they're just using the PPB stuff, which is just another way of encapsulating stuff internally.
Yeah, but it sounded like they didn't pop the outer tag when they delivered.
Just for to try and keep the timing.
Maybe it's a special case.
We need to discuss maybe. Sarah,
I'm not sure.
Kostas, can you reformulate the alternative that is on that slide and what decision? What decision we need to make or hear? Or is there no such thing?
I guess, okay, one outcome of the discussion is that perhaps we do not need to push information that is internal to the domains or specific to the reservations that have already taken place and build some additional functionality on the tree root, for example, and we could just follow along with how NSI considers things, that each domain can do its best to be able to reserve according to the requirements that it gets sent.
Henrik, what
I think both long term and short term, I think it's by far the easiest if you try to go NSI and not NSI and something else just for Autobahn. Because the idea with NSI is just NSI, you know, you should of course be able to wrap it around your existing system, but having this special thing that is just Autobahn is not going to be an advantage for you in the long run. It's just going to be more stuff you have to maintain and carry around, and it will make Autobahn harder to adopt for anyone else.
The trade-off would be that we would lose some of the functionality, let's say, or the capability that we used to have. But
in the reservation, or
sorry,
in the pathfinding or reservation,
yes.
or so. Now I'll start throwing the dirt around. Most NSI implementations can do reservation and reply within 1 second. Why does Autobahn always push 30 seconds or more? I can do 30 reservations into SurfNet sequentially before I get a reply back from you. That means I get 30 replies, and I can do ranges in my request. So I can say, I come in with this VLAN, get me any of these VLANs out. It's perfectly adequate.
Okay.
Just make your implementation good so it can reply fast. Then this problem goes away. It seems like you're putting an awful lot of workarounds to deal with this issue.
Yeah, because the thing is that Autobahn has been designed not as a single domain implementation, let's say. It was designed as a multi-domain tool from the start.
Maybe that's what we should, change a little bit, what it was and what it is going to be. Understand that it came from one point, but I think the world's changing a bit. So
okay, because I think there are still a lot of slides that we need to go through before. But I just want to say I think maybe it's I think the decision is partly into the technical team led by Kostas and by the people who have implemented Autobahn already. That means mostly the 9 NRENs, and it's to understand the trade-off, to understand what you would lose. Maybe we should list what we would lose, or what would be the impact of trying to go fully NSI also for this internal thing.
I also think that there is a problem if you try to optimize everything and get this holistic view. I mean, isn't that what it's all about? Again, trying to optimize, and maybe that's not the issue here. The issue is to just make sure the connection gets up when you try to get them up, and because you can spend a lot of time, trying to optimize, find the best path. I'm not sure whether that's what we lose, but if the flip side of that is that you're never going to reply, as Henrik indicates, within normal time limits, maybe you should just cancel that and say go for what you can get. But okay.
I think we should pull out the question, and then we should go through the other slides and maybe come back to that problem. So we steer time.
I have 2 issues, but I'll try and make it short. Firstly, you're talking about firewalling all the NSAs wouldn't scale, but of course it's a completely artificial limit that you impose upon yourself. Why not have port 80 simply open to the world, like you have on any other service, like email, etc., and only those who successfully authenticate can actually use it? Why build a firewall and then say everyone has to use our NSA because we can't keep up with setting up the firewall rules?
Okay, perhaps this is not a question I may be the best person to answer, but judging from the experience we got with the deployments that we did, 8, 9 deployments, it's not always trivial to open or I don't know if we make the assumption that any domain that wants to deploy Autobahn has to open, as you said, port 80 to the world, then okay, that of course simplifies the situation.
It doesn't have to be port 80, it has to be whatever port the NSA lives on. And
That would make
I
it
would not
easier,
even
but
say it's a requirement for Autobahn, but I would like to say it would be a very nice requirement to have in NSI even, that every NSA is open on port 80.
Okay, can we just maybe, just on that question, get some feedback of I don't know, Tomek or Leonidas or Sebastiano, I mean, as domain owners, on what's your standpoint regarding these firewall issues? I mean, because Kostas was presenting a model that simplifies your life.
Yeah, but
doesn't necessarily
the idea is that the NSA can control someone's network. So I don't know if the people are willing to give access to some specific port to the whole world. If they're okay with that, of course it's much better for us.
Leonidas?
Yeah, I'll try to shout. Okay. I think it depends. I think it depends on each domain's security policies. For example, we have a very strict policy. So we do not allow, we close everything and we only open something when it's needed. So I don't know about the others, but I think it's more or less the same with everyone.
But it obviously doesn't scale if you start to run a large service. If you consider it just a service like your email service, it just doesn't scale if you want to have every other server listed in your firewall.
And then for Dante?
Well, speaking for Dante, it's the same. Our firewall policies are really very strict, and we have to make request for an exception. So,
From personal experience, while setting up the Negios instance in Dante, I was amazed by how strict the security policy is. So they have this outgoing filter, whereas you would expect to have incoming filters. They have this outgoing filter. So, I mean, each one has its own policy, and that's totally respectable.
Yanni, you have an opinion?
On what? I was reading my emails.
You're open.
Well, I'm not involved in security in PSNC, but as far as I know, our security policy is similar to others. So everything is blocked, and then services which are required by users are allowed, but only particular services. There are, of course, some template for typical user, what typical user can access. So there are services defined like web pages, email, SSH and stuff like this. But they are usually outgoing services. If we are looking at the servers and services provided inside the network, so there is very strict policy, so every service must be unlocked separately.
And I think we could go around to the other networks and get very similar answers. So we need to take that into consideration.
Yeah, I think this means that it may not be wise to make such a requirement of the tool that you have to open a port for anyone. That may be a blocking point for some.
Can I ask a stupid question? Let's say Henrik's question saying this is one of the things that that contributes to Autobahn's provisioned networks or bandwidth on demand services or segments to be slower to answer than others. Could we, if that is the case, I mean, could we have like a two options in a way? I mean, either you have the strict firewall option, or you open everything.
The idea in that case is that we have to plan for the case that we do not have full control plane topology, full mesh topology. We have to plan for scenarios where reservations will have to be transferred from one NSA to the other, and not.
How does the firewall issue differ in these two scenarios? I mean, how many ports do you have to open in? Let's say you have Xiang in the middle there.
The main difference is this is what we currently have,
yeah.
And this has generally been quite easy to ask for some deployer. I mean, if this is Giant and this is HANet, they just have to open firewalls to each other IDM instance. And if this is some domain behind HANet, like Exemplar used to be, they just have to open the firewall to HANet and not to GRNet or some other domain that they perhaps don't even know about. Whereas in this case, this means that we have to have at least one central node, which can be Giant. This is actually something that's happening right now because everyone opens up their firewalls to Giant, at least. But it's a different thing from saying that everyone will have open firewalls to everyone. This is a stronger assumption, and I don't know if we're safe to make this.
If you want this in production within the next 6 months, as it is planned, I think it's reasonable to take to make our decision based on what's going to be allowed by the nodes regarding firewalls, and limit.
More or less, we know that what we have right now, so this allows these two situations. So we know that this is currently, because we already have similar deployments. So, was there another question by you?
Well, the other thing is at the moment the Autobahn thing is sort of, you have the domain manager and then you have the technology proxy.
Mm-hmm.
And as an actual user, what I run into quite a lot is that I try and do a reservation. It says, yeah, reservation confirmed. And then it's time to do the provisioning. And then the provisioning fails. So there seems to be a little bit of a, how do you call it? Schizophrenia between the two halves of the Autobahn that don't really, one half doesn't really know what the other is doing. And that sort of breaks how you would like to use NSI.
Okay, this is a valid comment, I think, because we have, as I showed before, the architecture of Autobahn, and which is planned to remain this way, is that we have actually what we send to the domains to deploy is this part, and then the technology proxy is an independent module that is the responsibility of each NREN to set up. And in many occasions, this is actually located in a different server. Mm-hmm. So this is software running on a VM, and this is software running on some separate machine. And when the domain manager, and this is a stateless module, which means that it has no knowledge of reservations. All it does is that it gets some requests to activate a circuit on a specific path or deactivate the circuit. And the way that Autobahn operates is that when the domain manager sees that some timer has expired and that it's time to activate a reservation, then it sends a message to the technology proxy saying that now you should configure for me this path. If the technology proxy is down, for example, or communication for whatever reason, and this is something that happens sometimes, then this means that the domain manager will get a failure back or a connection refused, and it will report that activation failed, what you said. But first of all, the fact that this is an independent module is a necessity because of the heterogeneity of the deployments. So we could not have this as an integrated module because there are different implementations. So it has to be something outside of the main Autobahn module. The improvements that I could see, for example, would be that the domain manager could, at various points, do some sort of checks to the technology proxy. For example, when you promise that you have scheduled a reservation, you could check the technology proxy that it's working. And that would be an improvement, but still, this would not rule out that, for example, if you make a reservation for tomorrow, the technology proxy might go out at night. So even then, you will be at the same situation. It's not that this is going to be fixed, because I think this is something that is related to the way that the software is architectured to work in a heterogeneous environment.
I think some of the problems you're referring to is also the problem we have with Juno Space, which is underlying. So I mean, it's not something that Autobahn is responsible for, unfortunately.
But this is also a different point, because you may connect to the technology proxy, but then the technology proxy, for whatever reason, is unable to talk to the underlying NMS. Or the underlying NMS, which in Giant, for example, is Juno Space, might throw an error. So this is something that...
However crucial it is, especially for me, to put the blame on Juno Space rather than Autobahn, we have another risk, which is like we're going to have eggs, so we need to eat soon. Otherwise, we'll all be dead and bandwidth on demand will not matter. So please go through your slides, and we can have the discussion. At the end of the day, we'll have time to reflect on what we've been discussing. But we need to...
I will just wrap up with the
testing plan and timeline are very important things.
Okay, so in order to migrate to version 3, we will have to set up different installations, completely new environments. The idea is that we can build a new service and test it before it's actually put into production. This means that possibly some new VMs might be needed by the NREN so that we can set up a parallel infrastructure side by side with the already working one. As I said, the CNIS and technology proxy remain the same, so no changes there. We cannot transfer the database, which stores active or reserved circuits or historical data. So this will all have to be archived, and any reservations will have to be recreated in the new instance. So we're now testing the software and fixing implementing the gaps that exist. Then we will start installing the new IDM instances. Assuming that we build up a parallel control plane, we can test this including multi-domain operations. And we can even connect this parallel control plane with the production data plane at a subsequent phase. And when we are satisfied with the operation of the new control plane, then we can shut down the old instances and switch, for example, the DNS of the portal to point to the new one, or take down the peerings or migrate them, and also migrate the API clients and all other external stuff. So the timeline is that we're currently testing the alpha release. We expect to have the beta release in December, so that we're able to start deployments in January. The migration has to be complete before the end of year 1, which is the final deadline. So that's all. I went through the plan a bit fast. I don't know if Tanguy or Brian want to add something here.
I think we need to eat, but there are, of course, like a series of questions, practical steps for the NRENs who have Autobahn, and also testing against Henrik's implementation, Hans' implementation. I mean, other NSAs. So we need to. We need to come with a more precise timeline and the very precise steps we do. But unfortunately, now we need to eat first. Unless there's a question or comment or someone as a big flag. You don't have a flag?
No, I'm hungry.
Okay. But we wait for people online. We start again at 2. So 2 p.m. CET, which is in approximately 45 minutes. Thank you.
Okay, thanks a lot.